Hello and welcome back to Elementary Algebra. We are ready to wrap up chapter 4. We're going to talk about the word problems today, but before we do that, let's review what chapter 4 was all about. So we started chapter 4 by talking about the system of two equations which produces either a unique solution, no solution, or infinitely many points as a solution. We obtained those solutions either by graphing or by what we see here, substitution method. So I would like to review both of those before we move on with word problems in this area. So we're going to take a look at two problems. One problem, which is two equations. So y equals 2x minus 3, and then x plus y equals to 3. So these are the two equations that are given to us, and we would like to find the solution. Now we already talked about putting this into context of the world around us, but we'll do the word problems later on, so obviously it will come back and it may make more sense. But right now we just want to solve two equations that we see in front of us. So we did that in two ways. Way number one in 4.1 was to graph these two equations. So we graph them and we see where the intersection is. So to achieve this, we had to start with, we have the first equation and the second equation. So we start with the first equation, which was negative 3 on y. And then we go, the slope rise over run over here is 2 over 1. If you don't have the denominator, you just put over 1. So rise 2 and run 1. You can go to the next point if you want. Again, rise 2 over 1. So you can make as many of these points as you want. And this line would go forever. Like that, you can label this as line 1. Now, line 2 was the interesting one because it's a standard form. So we use our xy intercept situation here, right, the setup. And when you plug in x equals 0, that kills x, so y is 3. And when you plug in y equal to 0, then you have x equals to 3. And both of these together, right, 3, 3, we can create our x and y intercept. So 1, 2, 3 for y intercept, and 1, 2, 3 for x intercept. And then we connect those two with a straight line. That's going to be our line number 2. We put these arrows usually at the end to signify that this will go on forever. So now, when we have the two equations, if we did this nicely, correctly, on the graph paper with a straight edge and so on, we can immediately see that the solution is here. It's 2, 1. It's the intersection of the two lines. So if the lines intersect, whatever the intersection is the solution. Now that solution doesn't have to be whole numbers, right, integers. It could be fractions, decimals, right, and so on. But, we try to come up with equations that have whole numbers as answers. And it doesn't mean that if you get, 1/2 is wrong. It could be wrong, especially if you are not drawing carefully, right, and not on a graphing paper and all of that stuff. So sure, it could easily be wrong. But if you have, proper instruments to draw this, then it should be all good. Now, we also have another way of solving this, which was, so this way over here was 4.1 way, and now 4.2 way to solve the problem is the substitution. There we go. And this is graphing. So we have graphing and we have substitution. Now for substitution, we already have y equals everything else over here. So we can just plug in this 2x minus 3 into y. So the second equation now looks like x plus, and here is this 2x minus 3 equals to 3. So this part over here is the y from equation 1. Now I add like terms. That's going to be 3x minus 3 equals to 3. Add 3 to both sides. Get 3x equal to 6. Divide both sides by 3 and get x equals to 2. And then we go and plug in into y equals 2x minus 3 to get 2 times 2 minus 3, which is 4 minus 3, which is 1. And here is the 2, 1 solution again. X is 2, y is 1. The same solution we had by graphing up there. So it is usually up to you whether you want to use one method or the other. However, we have a problem with graphing, especially when the numbers become large and the graphs become too stretched and you have to use scaling, and then the precision of your answer becomes an issue. So we don't use graphing too often. We use substitution method and then the other one called elimination method or addition method, which is 4.3, but that is in intermediate algebra, so we do not cover it in this class. But there is another method that you can use. So you will have two methods moving to your future math courses. But right now, we have this one method, substitution, which is algebraic method, and then one is graphical method, which could be very impractical, depending on the shape of the graph, right, the size of the numbers and scaling and all of that stuff. So this is what we did last time. We talked about graphing method to solve the equation, and we talked about this substitution method. So now that we know these two methods, we would like to figure out what we are going to do with these problems to apply them to the situations that we can find ourselves in. I did talk about briefly supply and demand for economics and business. I did mention picking the cell phone plan or picking the health insurance plan, even renting the car from, you have two different offers. These calculations are very useful because you can save money on the long run if you are using these things, especially when you talk about health insurance, and then if you are covering multiple people in the family and so on, it tends to be expensive, right? So picking the right plan is something that is very important. Now let's take a look at equation and try to make sense of how would we make the the word problem, right, and how we'll come up with a solution and make a choice. So I was hoping to find a problem, but let's see what we can do. Problem 74 in the textbook says that car rental costs $25. I guess this is per day, plus 25 cents per mile. Write the cost equation. So what is the cost equation for this particular situation? Well, cost equation C is equal to, you don't know how many miles you're gonna go, so that will be your X. So you have 25 cents times X plus $25 flat for the rental. So here's a 25 plus 25 cents per mile, meaning 25 cents for every mile. So you multiply the number of miles times the price per mile to come up with a cost that it's the mileage cost. So we have this equation, and I'm just going to say that this C, you can look at it as Y. So technically this equation here is Y equals 1/4 X plus 25. So technically this is the equation, because your 0.25, right, 25 cents, that's $0.25. And you do want a fraction there, so you have your rise over run, so you can easily graph this thing. So now we can come up with a graph, and this is what I said earlier, right? If you are graphing these equations, it tends to be hard because, see, your y-intercept now is 25. Usually when we draw our graph, we go up to 6 or 7, maybe 10, right? But you definitely never go up to 30 when you draw those basic graphs. So this is where you introduce scaling, where each box on your graph paper is worth not 1, but maybe 5 or 10 or even 100 units. So now if I want to graph this, I know that my y-axis is actually cost, which is money, and the x-axis are miles, because that's what x represented there, right? It was 25 cents times x, unknown amount of miles that you drive. And now you decide which way you want to have these divisions, and since we have a 25, we can either do 5s or 10s. Let's see if we can squeeze 5s. 1, 2, 3, 4, 5, 6. So there will be 5, 10, 15, 20, 25. I don't like it because it is too close to C, and this is a positive slope. The line will go up, so we won't be able to actually read the numbers. So, and since I know that I'm not going to have a negative cost, they're not going to pay me to drive the car. I have to pay to rent the car. So it's going to be positive money, and it's going to also be driving positive miles. I don't need these axes that are going into negative infinities, right? The one on the top and one on the bottom. So I'm going to redo this graph and only put the quadrant that is important to us, which is this first quadrant, right? And we can make that first quadrant as large or as small as we want. So now, when I plot my cost and miles, I can use, again, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And then I have my 20 and my 10 and my 0. And then, we'll see for miles. One of the other questions, it says, in the next question, they want us to check 100, which needs me to go twice as long up there to meet 100. Whatever, let's just draw the graph. We go 1 box up and 4 box over. So 1 box up, 1, 2, 3, 4 box over. 1 box up, 1, 2, 3, 4 box over. And we can have our line that shows the cost in terms of the miles that we drive.
I have a question.
Yes.
So I see you go 4 over, 1 up, 4 over. Why do you start with 4 over?
No, I go 1 and then 4. I went 1 up and 4 over because it's rise over run, right?
Mm-hmm.
So you rise 1 and then you run 4.
Yes, but then it, like, the first, like, you're at the 30 mark and you go 1, 2, 3, 4, then you go up 1 and then 4 over.
I first went from 25 up 1 to 30, and then went 4 over, right?
Yes, and then you did it again?
Again, yes. And I can do it again if I want to, right? You can do as many times as you want.
Oh,
So
okay.
the second set over here doesn't have to be there. 2 are enough. I just wanted to make sure that you all understand that you go 1 up and then 4 over.
That makes
Okay?
sense. Yes.
Awesome. So now the line, we start at, let me put the orange 25 right there because that's our y-intercept. And then we count 1 up, which will go into 30, and then 4 over. Now, the x-axis will have the same numbers as the y-axis. So every 2, we're going to have these, 10, 30, 10, 20, 30, 40, and so on. Good. So this is our graph. And now we can see how many miles we can cover with a certain budget. Sometimes when you work for a company, they will tell you your budget for this trip is going to be, let's say, $45. And you go to the rental company to rent a car, and you have $45 to rent a car. Now, the way you can also see how far you can go for $45 because you can draw a $45 line like this, and that line is going to hit your, so this is where the $45 is, and that line is eventually going to hit your linear line. And then you drop it down, and you see that you can go 80 miles for $45. This is how useful this graph is, because it will show you the intersection point here would be 80 miles, $45. So now to those previously nameless numbers, right? Now we add importance to those numbers because I discovered that I can go 80 miles for $45. Now, obviously, if I need to drive further, then the rental is too expensive. You can either downgrade the car or put up additional money from your pocket, right? Whatever it is. but the calculation here clearly shows that if the budget from the company is 45 bucks, then you can most drive 80 with the cost equation. So now we know when you go to the rental place, the size of the car, the whole bunch of things are important in the price, right? It's not flat rate for every car that is on the lot. So larger cars have different price per mile and daily rentals and all of that kind of stuff. So you can see that we actually intersected two lines. The black line, I'm going to erase this one for now. The black line is the equation, the cost equation, and the red line is the horizontal line. You can call that y equal 45, which is the line that I said, okay, you have $45 worth of money. Now the book is asking you to solve the same problem with 100, but as I said, for 100 I have to extend this line up and then find where the 100 line is, which is going to, ask me to extend the black line outside of the bounds. So it's not a pretty number to work with. So I went with 45 because with 45 we can easily obtain that the situation is you can go 80 miles. Now, if you were supposed to solve this in the form of the equations, where they give you that c is equal to 0.25x plus 25, and they also tell you that the cost that they're giving you, right, they're giving you $45 to cover the cost. Well, you can see that this is a very simple substitution problem where you replace c in the first equation with 45, and when you do the calculation, you will get x is 80. You have to, because that's what we got on the graph, given that the graph is done properly. So let's see. Substitution method would have me this plug in there. So my equation 1 now, so this is equation 1, this is equation 2. So my equation 1 now is going to be 45 equals to 0.25x plus 25. We subtract 25 on both sides. That gives us 20 is equal to 0.25x. And then dividing by 0.25. If you are using the calculator, obviously, you would do that. If you want to use your brain, then you would convert this into the better form, which is 1/4 times x, because fractions are absolutely amazingly powerful. Just multiply both sides by 4 to kill the fraction, and you have your x equals 80 instantly. So you are done with the problem faster than people figure out where the calculator is. You already have the solution if you know fractions. Now, if you don't want to bother with that, obviously no one will, right, make you. You can just use the calculator to divide 20 by 0.25 and you will get 80. So the meaning of this problem is that we can drive 80 miles for $45 at this rental agreement. If the rental agreement changes, all of the numbers change, obviously. If they agree to rent you for $20 per day, if they agree to give you 20 cents per mile rather than 25 cents per mile, like any of that stuff can change, right? And in that case, obviously, the whole calculation changes. Now, the company most likely will not negotiate 45 bucks, but the two competing car rental places might be coming down with a price just to have the business, rather than you walking away to the other business to rent a car. So there's that.
Can we do another one of these problems?
We're going to do another 3 if you don't mind. Next one can be supply and demand, which I mentioned earlier. And again, it doesn't really matter which problem we choose. One is about donuts and the other one is about e-readers. Which one should we do? Donuts or e-readers?
Donuts.
Donuts. Okay. That would be 78. Love it. Oops. Love the enthusiasm. All right. So the quantity of donuts bakery supplies per week at the price P is, they say, QS equals to P. And the quantity of donuts the customers demand at the price P is QD equals 9 minus 2P. So businesses that are large businesses, the companies and so on, they hire mathematicians to come up with this stuff. Because once you have an equation, you can always predict and compute how well your company is going to do. So obviously, if you're running a donut shop out of your kitchen, you're not going to be doing this, but you're also not going to ever become a millionaire. That's a thing. If you have a large-scale business, then cost and supply, demand, all of these stuff, profits and revenue, that all has to be computed, that all has to be known way before you actually run into any, you start dealing with any kind of business in terms of the product you are planning on. So in this case, a supply is the amount of stuff that you can make, whether it's your kitchen bakery or it's a whole mega factory producing millions of units a day. So supply is something that you can make and supply to the market to sell. Demand is what people want to buy. So when people see a product that they really like and they find very useful, they will create what it's called the demand, because people would pay money to have that product. And obviously, you keep rising the price as a company until you start losing demand, right? Because when the price is too high, a lot of people don't want to buy it. When the price is right, a lot of people buy it. And then obviously, if you put the price too low, then you are losing money and profit for the company. So the companies are always playing this game, supply versus demand. And the very important point on this supply-demand graph is something that it's called the equilibrium point, which is the best price that you can have for your product. Now, we're not going to go into specifics from macroeconomics class where, I learned this stuff, let's say, for the first time. And today, it's very easy for me to understand why and how these businesses are doing well, why Bezos is so rich, and he should be actually richer, just because he has the business model that everyone wants to use. He has the best business model for all sales on the entire planet. So of course, when you are doing business with pretty much the entire planet, you are going to be very rich. That is absolutely normal. Like that's clear as a day. So when you have these now equations, I need you to look at them in this light. Y is equal to x and y is equal to negative 2x plus 9. So what I did here is I just took the variables of q and p and converted those variables to your good old x's and y's that you are very familiar with. And then further, I can also put 2 over 1 over here because we like a fraction for our slope, so that we can graph the slope. So let's talk about the graph. Now all I need to do is to graph this thing. Now again, we are going to use this type of a graph. I don't need any negative sides, because what you have for your x and a y are your x-axis here is a price, and over here is the q on y-axis, which is the quantity. And what I can do now is I can graph these two lines. So y equals x is the line that always goes through the, like this, at what we say at 45-degree angle. It's a line that goes through every corner of these boxes diagonally, like this, right? So it goes through all of these boxes at the 45-degree line. So it just goes like this. So this would be your equation 1. This is your equation 1. This is your equation 2. Also over here, 1 and 2. Now equation 2 has us to go up 9 and then do the negative 2 over 1 drop. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we are going to drop down 2, go over 1. Drop down 2, go over 1. Drop down 2, go over 1. And we draw this thing like this. This point here is the solution point. Now in economics, I told you it's called the equilibrium price, which is the best price to set for your product. So now what happens here is, if you take a look at this, it appears that that's $3, right? The price is in dollars, and it is, in this case, the solution is 3.3. So what do they say? Where price is in dollars and quantity is in hundreds of donuts, determine graphically the number of donuts the bakery should sell at the corresponding price per donut. Very good. So the quantity is the second. Unfortunately, it ended up being 3.3. So yeah, not too good of a situation here. But the 3.3 solution in this case, where we know that this is our price, means $3 per donut, and over here quantity is 300 donuts, because they say that you're supposed to sell 300 donuts at $3 per donut. So that's going to be $900 in what you call the revenue. Then from those 900, you have to deduct the cost for all the materials to make the donuts, and the worker price, and electricity for the oven, and all of that kind of stuff. So there are a lot of stuff that you have to pay out of those $900, and then whatever is left over is what is called profit. So there is a lot of things that go into this. So in this word problem, we had the supply equation, which was quantity of the supply was equal to the price. And then we had this one over here, which is the demand, right? Which is what you do that with the market research. So if you ever heard of marketing and you want to, study marketing, then actually this is what you are technically are supposed to do. You're supposed to do the market research and figure out whether a particular product or goods is desirable by people to buy it. And you are supposed to research the market and see what else is necessary for the market, right? Marketing is not commercials. That's a very advertising is a very small part of marketing for the product. It's not marketing is not ads and commercials and promotions and things. It's the part of it, but the biggest part is to actually do the market research and figure out what are the products that the people want, and actually you are steering the company. It's a very important part of the company, but people usually misunderstand what market is about, and mathematics is a big part of marketing as well. Some colleges even require calculus to get their degrees in marketing, because calculus studies is a study of change, and the markets change over time. People's wishes and aptitudes change over time as well. So study the change is also important. So that's all the part of that. Let's see what else can we do. But in a long run, before we do a next problem, you have equations that are either given to you or you figure them out, and then you convert those equations into, you can write them if you want your x's and y's, and then you just draw your graph, and that would be all good. Let's take a look at more of these problems, at least two more. We can do exercise and calories. That might be a good one. Okay, so 48-minute workout. Burns 450 calories. On a tread climber and stationary bicycle. So I'm gonna say treadmill and bicycle, but it's tread climber and stationary bicycle. So the student burns 12 calories per minute on this one. So 12 calories per minute, and burns 5 on the bike. Okay. So they want to know how long was this student using each exercise, right? The tread climber and the stationary bicycle. So how many minutes on each, for a total of 450. Now, this is something that you can actually figure out using the old equations, because the chart for this looks the same. If you remember the chart from before, we said that you're going to have your, let's say, treadmill over here, you're having your bicycle, and you're going to have your total. Then you're going to have your your minutes over here. You're going to have your calories per minute over here, and then you're going to have calories in the last one, because minutes times calorie per minute, minute and minute cancels, so it is this times this equals that. And what you used to do is you used to say, if this was x, sorry, before you do that, you say the treadmill or whatever it was 12 calories per minute, the bicycle is 5, total of 450 burned in 48 minutes. So as you can see, this is identical, and we can solve this problem using the methods from your chapter 2, right? Because I can fill this as x, and then 48 minus x, if you remember, and we just go with the calculation, right? You have your 12x, and you have your 5 times 48 minus x. Add these two, equal it to the one on the bottom, and this is what we did in chapter 2. Now, how's chapter 4 different? Well, it's going to give you the same answer, but now instead of writing 48 minus x here, we're going to put a y, and then you're going to have two equations to play with. So absolutely same chart, because it's the same information given to us. We have a treadmill, we have the bicycle, we have the total, we have our 48 minutes, we have our 12 and a 5, and a total of 450 calories lost in 48 minutes. Now, if you want to solve this problem using chapter 4, two equations, two unknowns, and all of that stuff, then you can put x and a y here. You say, I don't know how long the student was on the, what was the first one? Some kind of tread climber, okay? And the second one is y. I don't know how many minutes the student spent on the stationary bicycle. So altogether, this is just 12x, and this is a 5y. So if you look at these two columns here, they give you equations. There is x plus y equals 48, and 12x plus 5y equals 450. So you can do it using chapter 2 still, but if you go into chapter 4, you can, instead of placing this 48 minus x, you can put y and then have two equations. So now we just need to use the steps we learned in class, where you pick a single x or a single y and you solve for it. So from the, let's say, first equation over here, you can say that when you subtract x on both sides, you can say that y is equal to 48 minus x. Do we remember 48 minus x from somewhere before? Right? These things are all connected, obviously. And now you will plug that in second equation. So first equation ended up being this. The second equation is 12x plus 5 times, here's your 48 minus x, equals to 450. That's going to be 12x plus 5 times 48, that's 240, minus 5x equals to 450. 12x minus 5x is 7x, plus 240 equals 450. Take away 240 on both sides. And here is your 7x is 210. Dividing by 7, we get x equals 30. So x equals 30, meaning that the student was 30 minutes on, I keep forgetting what this thing is. Thread climber, okay. Thread climber, and then 18 minutes on stationary. Is it stationary bicycle? Yes, stationary bicycle. Okay. Together, 48 minutes, right? 30 minutes on one and 18 minutes on the other. So what you see here on the screen is the chapter 4 way to solve the problem that could be a problem from chapter 2, right? And I gave you the old way as well up there so that you can compare new versus old. This question could have been on your first exam easily because you can use 2.3 or whatever, 2.4, whatever it was, word problems. You can use that method perfectly fine to solve this question. But here is also chapter 4 way to solve that question. And we really have to do one of the speed problems because generally those pop up on exams and final exam and so on. So we should, maybe I should have written here that x plus y equals 48 and then 30 plus y equals 48, y is 18. Just to make that clear, right, where 18 came from. You can compute that. So let's take a look at the standard problem, the speed problem, where an airplane flies 1,200 miles into the wind in 3 hours and the return trip takes 2 hours. Find the speed of the airplane without a wind and the speed of the wind. Now, we have to be very careful reading these problems because flying into the wind, that's clear. Wind is not going to help. But it says, and the return trip takes 2 hours. Does not mention the wind. That means no wind. It's not that, yes, you are going the opposite way, but it didn't say with the wind. So you have to be very careful about that because it changes your equations. And let me show you the graphics so you know if the airplane, that's the airplane, is flying this way with the speed of the airplane and the wind is pushing this way, then let's call this actually speed of the airplane sa and speed of the wind is w. So the overall speed is the speed of the airplane minus speed of the wind because wind is not helping. Wind is against the airplane, so the airplane is actually flying slower because the wind. It's the same thing. Are you swimming up the river or down the river? If you're swimming up the river is flowing against you, so you have the current against you, and then you have to swim slower. Now, the airplane coming back is going to have this speed of the airplane this way, and it could have the same wind as before, help it. So now the speed is speed of the airplane plus speed of the wind, because wind is helping. Now, what is important to understand in this problem, on the return trip, they never said there was a wind. Okay? They never said there was a wind to help the plane. The plane is flying under no wind conditions. That's possible, right? Therefore, the wind is not helping, the wind is not making it worse, right? It's just no wind. And that is important, because if they said in the text that the plane was going against the wind, that's against the wind, you have to subtract the speed of the wind. When it's going with the wind, then you will add. But when they mention nothing, that means there is no wind whatsoever. So now, when I'm writing my equations, and we know we are using the dirt equation, right? Where this is your speed. We know the situation. We draw a diagram to help us with this. 0 to 1200 miles in 3 hours. That is when the plane is going this way. Plane going back is covering the same 1200, but in 2 hours, and there is no wind. So what are my equations? Well, the rate on this one, on the black one, right, is going to be speed of the airplane minus speed of the wind, because the airplane goes against the wind. Coming back, the rate is just speed of the airplane. Wind is not helping at all because there's no wind, right? So if you want to think that the wind is going to the right, to the left, right, all the time, it should be helping in the red case, because the plane is going to the left. But they never said anything about the wind in the problem for the plane coming back. Therefore, we are not going to use it in our equation at all. Now, what are my equations? Well, the top equation is 1200 mile trip is SA minus SW covered in 3 hours. This is the distance D, this is the rate R, and this is the time T. D equals RT. So your rate, your speed, is going to be the speed of the airplane minus the wind, because wind is not helping. The second equation, the red equation, is you're covering the same amount of distance of 1200 miles, because you just go back home, right? And in this case, is just SA times 2 hours. Now, it also makes sense that if the airplane is going at its, whatever recommended speed, it clearly, right, common sense, it should take longer when it's fighting the wind than when there is no wind. And it would even be faster if it was going with the wind, because the wind would help, right, push a little bit. So the airplane might be there in an hour and a half, let's say, if there was a wind on the way back, but there wasn't. All I need to do now is to simplify these two equations. I have 3SA minus 3SW equals to 1200, and 2SA is equal to 1200. All I need to do is to calculate from the second equation here that SA is 600, and that's going to be 600 miles per hour. So that's the speed of the airplane. That's really fast, but whatever. And then you take that SA 600 and you plug it in SA to figure out the speed of the wind. So that's going to be, again, this is equation 1, this is equation 2. So equation 1, 3 times 600 minus 3 SW equals to 1200. That's 1800 minus 3 SW equals to 1200. This is really bad problem. These numbers make no sense in the real world, as you would call it, because I'm getting negative 600. I'm getting a 200 mile per hour wind, guys. That's we freak out when hurricane hits 160, right? Look at this. Like if you ever had the window open when you're driving 60 miles per hour on a highway, or 70 miles per hour, you know what the wind is at 60 or 70. Imagine 3 times more. This is really a bad example in terms of numbers for the real situation. I kind of want to redo it just to see if they forgot to put the words in against the wind, or sorry, with the wind for the return trip, because that could probably move these numbers into a better spot. The way they worded the problem, speed of the airplane, is 600 miles per hour and speed of the wind is 200 miles per hour. Again, the craziest hurricanes that literally level everything in their path would be 200 miles per hour winds. There's no way that the airplane would fly into that and you know, survive a 1200 mile trip. So my suspicion is that they wanted to put and just drop those words. I made a big deal about it in the beginning of the problem. So if you decide to redo this problem and just practice, change this SA over here into SA plus SW. If you want to practice this and have the wind help, right? So wind to stick around for the return trip and have the wind help the airplane on the return trip. Everything stays the same. Your just calculation obviously will change, and yeah. So that would be the thing to fix. But again, it wasn't in the word problem, so I didn't use it. That's it. I hope you're not disappointed with word problems. We can even go back to 2.3 or whatever the word problems were in chapter 2 and solve any one of those mixture problems using now 2 variables, because all we need is a problem of any kind. Was it 2.3 or 2.3, introduction to problem solving? Yeah. Trying to remember which problem did we do in class. The coffee mixture we did, and a coin mixture, I remember. Let's take a look at the coffee problem, and you can just take a look at the old notes. So one more problem, and then we'll talk about the exam date. So coffee mixture problem, this is in 2.3, solved by 4.2 method. More expensive blend of organic coffee costs $12 per pound, and a cheaper brand is $7 per pound. Good. I call this the intelligence test. Slap organic or something and just double it in price. For no reason. Anyway, so we have a coffee one. This is going to be pounds. It's going to be money per pound. And what you get is money, which is cost. So what they say, first one is $12 per pound. The second one is $7 per pound. And how many pounds of each coffee to make the 8-pound bag? So the total of it should be 8 for the cost of it to be $83.50. So this is your standard setup for the problem using the chart from 2.3. And again, the way you did this is you said x and then 8 minus x. Now we're not going to go 8 minus x. We're going to go y over here. And when you multiply across, you get your 12x and your 7y. And now there are your two equations. X plus y equal 8. And 12x plus 7y equals 83.50. So again, the problems for 2.3 and 4.2 are the same problems. You can solve it with either of the two methods. Some people don't like that 8 minus x. So for them, this would be preferred way of solving. So now you have two equations again, two unknown quantities, x and a y, which is one is the weight for the organic coffee and the other one is the weight for the, I guess, inorganic, non-organic, whatever it's called. So from equation 1, y is equal to 8 minus x, right? You can also solve it for x. It doesn't really matter. So subtract x on both sides, let's say. You can also do it with y, and you get your y equals 8 minus x. That's the 8 minus x that will go here. That's the one, but whatever. And now plug that in into the equation 2. So 12x plus 7, 8 minus x, equals to 83.50. $12x plus 56 minus 7x is equal to 83.50. 12 minus 7 is 5x. 56 equals 83.50. Minus 56 on both sides. 5x equals 2. There is still 50 on this side. That's a 7. And then we stole 1, so it's 2. When you divide both sides by 5, they cancel. X is equal to 5.5 pounds. So X is 5.5, and remember that the Y was 8 minus 5.5, which is 2.5. So we need 5.5 pounds of organic coffee and 2.5 pounds of the other one. This is what gives you the final 2 points. If you do not have a sentence which you are supposed to type in Canvas, on the exam, you are losing points for interpretation, presenting and presentation and interpretation of your solution. So the sentence is required for every word problem all the time. And in Canvas, it would be the only thing you type would be the sentence with these numbers in it. And the rest of the work, you will take the picture and you will email that after the test. But you have to have this. So solving the entire problem, everything you see from the chart through these equations and writing these two, it's all 8 out of 10. Once you reach here, that's 10 out of 10. You have to write the sentence answer to make it clear that you understand what happened in this problem and how you can use it to run your business. Questions, concerns, anything at all? Just crickets, huh? Okay. Then we are going to say goodbye.